So over here, as you can see, we're given a graph of f of x with certain indicated points, like this point down here. This is the point 0, 1. We're given the point, this is the point 2, 2. You cannot tell those are 2's though. That's the point 2, 2. We're given the point that looks like the point 3, 3, and then finally we're given the point 4, 5. Those are the obvious points. In case you couldn't tell by the terribly drawn graph, then those are what those points on the graph are. And we're asked the question, using the graph of f of x, so using this graph over here, what is the approximate value of f prime of 3? So normally the way we do is if we're given a function, as we are here, we're given a function, we just take the derivative, plug in f prime of 3, it gives us a number, we're good to go, we're happy. Except that I noticed that they didn't give me what f of x was. They gave me a graph of f of x, but they didn't tell me exactly what f of x is. I mean, we could guess that this is an exponential function, or a power function, because, anything to the 0 power, that's just 1. But, I mean, for all we know, this is just half of a parabola that happened to be shifted up 1 unit. So we don't know anything about this graph other than the points indicated. So we can't take the derivative of this graph, which is very concerning. How do you take the derivative of this graph? Well, you can recall that the way we find derivatives is by finding slopes of the line, that a derivative is the slope of the tangent line at that point. So we want to find the approximate value of f prime of 3. And we've been, again, doing derivatives in red, so I'll do that in red. Well, that's the same as finding the slope of, let me take a little bit of time. That's almost like finding the slope of this red line here. So we want to find approximately what is the slope, roughly that's what it looks like. So what is the slope roughly of that line? And it doesn't really pass through any other points in the graph. I should probably draw it a little bit more clear. It only passes through this point right here, this singular point 3, 3. We want to find the slope of that tangent line. Well, using our basic algebra ideas, we can only find the slope of a line if we know. Well, in order to find the slope, we need 2 points. But the problem is we're only given 1 point on this line, so we're not going to be able to find the derivative. And this is where, in order to approximate the derivative, we can approximate the derivative by drawing the slope, or not drawing the slope, but figuring out the slope of the secant line. So what does the secant line look like? Well, a secant line is going to be a line that passes through 2 of these points, and I want to do this in a different color. So this is an example of a secant line. It goes through the point 3, 3, and it goes to the point 2, 2. And you can see that this is a pretty good. The slope of this light blue line is pretty similar to the slope of the. I wanted the line under it to be red, and I'll go back and fix that. So I ended up drawing the slopes of all the secant lines that we could possibly draw. We could also do points relating to this point 0, 1, but I think we get very, very weirdly steep. That was a bad line. We get a very weirdly steep slope that wouldn't be anything like it. So the red line, as you can see right here, there's our red line right there. That is the slope of the line. That's the line whose slope we're trying to find. When we can approximate it with the slope of any one of these 3 other lines. So we can see this dark blue line goes through the point 3, 3 and the point 2, 2. We could also use the light blue line, which goes through the point 3, 3 and the point 4, 5. We could also use the slope of this orange line, which actually doesn't go through 3, 3, but goes through the point 2, 2 and 4, 5. You could use the slope of any one of these 3 lines, and that would be a good approximation of the slope of this red line. And of course, the slope of this red line is the derivative we're trying to find. So that's how you can approximate the value. So why don't we actually evaluate each of these approximations? So we're given 2 points on all those secant lines. We're given 2 points. We're given, like, for example, if we take this dark blue line, we want to find that f prime of 3. Well, that's going to be roughly, it's going to be, we're given f of 3 and we're given f of 2 on this line. So it would be, slope is, we want to find the slope of that line, so slope is y2 minus y1, f of 3 minus f of 2, over x2, which is 3, minus x1, which is 2. And so that's going to get us, well, f of 3, that's 3, and f of 2, well, that's 2 over 3 minus 2, and that would give us an approximation of 1. So you could say a correct answer to this question would be, well, the slope is, it's roughly about 1 using this secant line. You could also approximate it using the light blue line. We notice that the light blue line uses the points uses the points f of 3 and f of 4. So we could say y2, in this case y2 we're going to say is f of 4 minus y1 over x2 minus x1. That's how you find slope. Well, y2, f of 4, that's 5, minus y1, again that's 3 over x2 minus x1, that's going to be 2 over 1. You could also, a correct answer would also be that it's roughly about 2. And then finally, you could use the slope of the line that actually doesn't go through 3, but it goes through 2, it doesn't go through f of 3, but it goes through 2 points around roughly what f of 3 would be. So we use y2, which is looks like it's f of 4, minus y1, which is f of 2, over 4 minus 2. And that's going to get us, let's see, f of 4, that's 5, minus f of 2, that's 3. Yep, no, f of 2, that's 2, my bad, over 4 minus 2, and that equals 3 over 2. So you could also say that, f prime of 3, it's roughly 3/2. So we notice that the best approximation, if we look at this graphically, the best approximation looks like it's probably this orange line. That looks like the best one. So if you want the best approximation, you might want to choose the closest 2 points you're given around where you want to solve for it. If that's not given, you can always just pick that actual point, f of 3, and any really close point around f of 3. But all 3 of those would be acceptable ways to approximate f prime of 3.